In this video, I'm going to take a look at working out a couple of examples of solving log equations that have different bases, such as this first one's got a base of 5, a base of 7, and a base of 25. Alright, we're going to primarily use the change of base formula to make them so that we have like bases, and then the equations are going to be relatively easy to solve. Two examples because specifically two different ways to use this. Most of the time you use this change of base formula and it changes it with just a base of 10. You could also do this with natural logs, natural log of m over natural log of b, which your base would then be an e. Alright, but since we've got the log here, then we'll go ahead and use this with a base of 10. So implementing each one of these and that change of base formula, I'm going to have the log of x over the log of 5 plus the log of x over the log of 7 is equal to the log of x over the log of 25. Alright, now if I'm going to try to solve for x, I need all my x's on the left hand side, so I'm going to go ahead and subtract this from both sides of the equations. So I would have the log of x over the log of 5 plus the log of x over the log of 7 minus the log of x over the log of 25 and equaling 0. Now I have a common log of x in the numerator, so I'm going to factor out that log of x. So log of x times 1 over log of 5 plus 1 over log of 7 minus 1 over log of 25. That's equal to 0. Alright, now we've got two things being multiplied together here that equal 0. So one of these two things has to be 0. Alright, but you can look at this right here and a quick look at that. You have all numbers here, a number plus another number minus another number. This is not going to equal 0. Alright, so you can just look at that. If you need to verify that, you can plug that in the calculator and you can see that that's not going to equal 0. So what I've got to do is then take this log x and set that equal to 0. That's where my x is. Alright, anyway, I'm trying to solve for x, so doing this, I can recall that there is an imaginary base of 10 there. And so I can go from logarithmic form to exponential form really easily here. So 10 raised to the 0 power equals x, and then anything raised to the 0 power is always 1, so 1 has to equal x. So initially looking at that, you wouldn't have thought it was going to turn out to be that simple, okay, but using and applying that change of base formula turns out to be kind of simple. Alright, now for a second example. Alright, now this time when I implement that change of base formula, I don't necessarily want to go to a base of 10. I can choose any base I want. Alright, let's rewrite that change of base formula over here. Alright, log of m to some base, alright, equals log of m over the log of b. Alright, now writing the formula like this, leaving that base right there as a 10 is usually the easiest way to do it. However, I could say the log of m base 5 over the log of b base 5. I can choose this base to be any base I want. It doesn't have to be 10. Alright, so on this example, I've got a base of 4 and a base of 16. It's going to be easier. I want these to have the same bases so that I can use my laws of exponents and compress them into a single log. And so what I'm going to do is this first one, I'm just going to go ahead and leave it a base of 4, and I'm going to rewrite this using a base of 4 so that I will have matching bases, and then I can compress this log. Okay, so first one, I'm not going to change here, so log of x plus 2 base 4, alright, minus, now change the base formula, and I'm going to choose my base to be a 4. So that's going to be log of the x squared minus 4 base 4 all over log of 16 base 4, and that's equal to 1. Alright, now from there what I'm going to do is take a look at this denominator right here. This is the log of 16 base 4, and I think I'll do it over here. That's all numbers. I can evaluate this. Okay, so log of 16 base 4, all right, equals some number. I don't know what the number is. If I write it like this, I can go to exponential form. 4 raised to the x equals 16. What number has to go in there for x to get 16? Well, obviously that's going to be a 2. 4 squared is 16. So this has a value of 2, and when I rewrite it in this next step, I'm going to pull it out in front as a 1/2. So then I'm going to have the log base 4 of x plus 2 minus a 1/2 log base 4 of an x squared minus 4 equals 1. Alright, and then we are going to apply the rule that says I can take this coefficient here and pull it up as an exponent, and remembering that to the 1/2 power is the same thing as writing this as a square root. So when I pull that up on as a 1/2 exponent, I'm going to write this as a radical. So then I'm going to have the log base 4 of an x plus 2 minus the log base 4 of the square root of x squared minus 4 equals 1. Now I am down to a quantity on the left-hand side here that I have common bases for, and I am subtracting logs with common bases. So when subtracting logarithms, I can write this, condense it into a single log using division. So then I'm going to have the log base 4 of an x plus 2 over the square root of x squared minus 4. Go ahead and put that set of parentheses in there just to keep it isolated. It's still equal to 1 because I haven't done anything to that right-hand side. I have a single log equation now that I can go into exponential form. So 4 raised to the first power equals that. So 4 raised to the first power, of which I wouldn't need the 4 there, is equal to x plus 2 all over the square root of x squared minus 4. Now at this point, it is just a lot of algebra that we need to crank out to be able to solve this equation. And I think I'm going to take this and go to another piece of paper so that I have plenty of room to write here. So rewriting that expression from the previous piece of paper I had, 4 is equal to, I had an x plus 2 all over the square root of an x squared minus 4. Alright, so I'm going to multiply both sides by that radical so that I can get rid of that rational expression there. So 4 square root of x squared minus 4 is equal to x plus 2. Now I need to get rid of that radical right there. So the opposite of square root is squaring something, so I'm going to square both sides of this equation. So then I'm going to have on this side, I'll have a 16 times the quantity x squared minus 4 is equal to, squaring this out, I'm going to have a trinomial, x squared plus 4x plus 4. Distributing right there, 16x squared minus 64 is equal to x squared plus 4x plus 4. Alright, I can see now that I'm going to have a quadratic equation, so I might as well go ahead and move everything over here to the left. I want that leading coefficient on that x squared term to remain positive, so I'm just going to move everything over to the left. That's going to give me a 15x squared, subtracting that 4x from both sides, subtracting that 4 will give me a negative 68, and then equals 0. Now at this point, because those two numbers are extremely large, I would not recommend guessing and checking on this at all to try to factor it. I would probably immediately do a quadratic formula, so identifying 15 as A, negative 4 is B, and negative 68 is C. I would probably jump right into that quadratic formula. Alright, so we're going to have x is equal to a negative b, so that'd be a negative 4 plus or minus the square root of b squared, so negative 4 squared minus 4 times the a times the c all over 2 times a. Alright, and seriously, at this point, it is a lot of arithmetic. Okay, so I would probably maybe pause the video, grab your calculator, see if you can finish working this out, because it is just arithmetic at this point. We're going to have a 4 plus or minus the square root of a 16. Actually, let's just go ahead and do that whole entire thing in a calculator. That's going to give you 4,096 all over 30. Alright, and then finishing up here, I'm going to have x is going to be equal to 4 plus or minus 64 all over 30. That'll separate into two separate answers of 68 over 30. And then negative 60 over 30. Reducing here, this will give me a negative 2. Reducing here, this is going to give me 34 over 15. Alright, now I've got two possible answers here. Now, you got to remember what that original problem was that we started with. So I'm going to fold the paper and pull that back up just so we can talk about that a little bit here. Okay, so this was my original problem right here. Now, whenever you're doing log equations, you definitely need to take both of these answers and check them back in. I'm going to start with this negative 2 because when I plug this negative 2 in right here, negative 2 plus 2, that's going to give me a 0. So that right off the bat, there's two things you cannot take the log of. You cannot take the log of a negative number, and you cannot take the log of 0. So right away, that's going to let me know that the negative 2 is an extraneous root, so then my only answer to this equation is going to be 34 over 15. Would I go ahead and check both of those? Yes, I would, so you can pause the video and do that, but it definitely does check there as being a final answer. So definitely, thanks for watching this solving log equations with different bases. You implement that change of base formula and you should be good. Definitely, thanks for watching, and don't forget to subscribe to the channel. Thanks.